The 1815 Mount Tambora eruption. The eruption of Mount Tambora in Indonesia in April 1815 stands as the most powerful volcanic event in recorded human history. What made the eruption of Mount Tambora significant is the fact that it affected global weather patterns. At the time of its eruption, Tambora ejected an estimated 150 cubic kilometers of material into the atmosphere. This was roughly 100 times more than Mount St. Helens eruption in 1980. The explosion was so powerful it was heard over 1,000 miles away in Sumatra. The mountain itself lost nearly one-third of its height to form a caldera, measuring approximately 4 miles wide and 3,600 feet deep. The initial damage resulted in the deaths of approximately 10,000 people due to pyroclastic flows and tsunamis. But it was the after effects of the eruption that resulted in the greatest loss of life. The volcano pumped vast quantities of sulfur dioxide into the sky, where it converted to sulfuric acid that circled the northern hemisphere, blocking sunlight and lowering global temperatures by an average of 0.7 to 1.3 degrees Fahrenheit. The consequence became known as the Year Without a Summer in 1816. Crop failures were widespread in the northern hemisphere as killing frosts occurred even in summer months. Snow fell in New England in June. Across Europe, harvest failures were disastrous. Food prices soared to 10 times normal levels, triggering widespread famine. The death toll from starvation, disease, and hypothermia reached approximately 80,000 on the Indonesian islands near Tambora, with worldwide deaths due to the climatic changes estimated at more than 100,000 and possibly approaching 250,000. The vivid red sunsets created by volcanic particles in the atmosphere inspired numerous artists. The weather during the summer of 1816 confined Mary Shelley and her companions indoors during their Swiss holiday, leading to the ghost story competition that ultimately produced Frankenstein. The 79 AD Mount Vesuvius eruption. The eruption of Mount Vesuvius in 79 AD stands as history's most famous volcanic disaster. When Vesuvius erupted on August 24th, or possibly October 24th, according to recent evidence, it released thermal energy equivalent to 100,000 times the atomic bombs dropped on Hiroshima and Nagasaki. Prior to the eruption, Vesuvius wasn't widely recognized as an active volcano after centuries of quiet. Having been dormant for hundreds of years, it was considered simply a mountain. Minor earthquakes had occurred in the region for several days before the eruption, but these were common in Campania and raised no particular alarm. The eruption began around midday with a massive explosion that sent a column of ash, pumice, and gas approximately 21 miles into the sky. For several hours, light pumice and ash rained down on Pompeii, accumulating rapidly, collapsing roofs under the growing weight. The truly devastating phase began early the following morning when the eruption column collapsed, generating a series of dense, fast-moving clouds of hot gas and volcanic matter that swept down the mountainside at hurricane speeds with temperatures reaching 700 degrees Fahrenheit. These flows engulfed Herculaneum and later reached Pompeii. The eruption buried Pompeii under 13 to 20 feet of volcanic debris, while Herculaneum was covered by pyroclastic rocks reaching depths of 75 feet in places. What makes Vesuvius archaeologically significant is the manner of preservation. In Pompeii, many victims were encased in falling ash that hardened around their bodies. As their remains decomposed, they left hollow spaces that archaeologists later filled with plaster to create detailed casts of the victims in their final moments. The excavations revealed a complete Roman town frozen at a precise moment in time. Loaves of bread were still in ovens, shops were fully stocked, and election notices were still on the walls. Today, Vesuvius is considered one of the world's most dangerous volcanoes due to the population density surrounding it. Approximately 3 million people live in the immediate vicinity, with Naples just 7.5 miles away. The 1883 Krakatoa eruption. The August 1883 eruption of Krakatoa in the Sunda Strait between Java and Sumatra created the loudest sound recorded in human history. After several months of increasing steam and ash emissions, Krakatoa entered its paroxysmal phase on August 26 to 27th with 4 enormous explosions. The final explosion at 10:02 a.m. on August 27th was heard 3,000 miles away, which is equivalent to hearing a sound from New York and Dublin. The explosion essentially destroyed the island, which collapsed into the caldera created by the emptied magma chamber. Approximately 6 cubic miles of rock were blasted into the air. The deadliest aspect of Krakatoa was not the eruption itself, but the tsunamis it generated. When portions of the volcano collapsed into the sea, they created waves that reached heights of over 120 feet in some coastal areas. These tsunamis destroyed 165 villages along the coasts of Java and Sumatra, causing the death of an estimated 36,000 people. Krakatoa's global effects were profound. The ash and aerosols injected into the upper atmosphere reduced global temperatures by an average of 1 degree Fahrenheit for the following year. The sunlight filtering through these particles created spectacular, colorful sunsets worldwide for nearly 3 years. What made Krakatoa historically significant was that it occurred at a pivotal moment in telecommunications history. The recently installed worldwide telegraph network enabled news of the disaster to spread globally within hours, making it one of the first natural disasters reported globally in near real time. By 1927, a new volcanic island, Anak Krakatau, meaning child of Krakatoa, had emerged from the caldera. This volcano remains highly active, and a partial collapse in December 2018 triggered a tsunami that led to the death of approximately 437 people. The 1902 Mount Pelée eruption. The 1902 eruption of Mount Pelée on Martinique provides one of history's most sobering lessons about volcanic hazards and the consequences of ignoring scientific warnings. What makes this eruption particularly significant is that it introduced volcanologists to the deadly potential of pyroclastic flows. In April 1902, Mount Pelée began showing clear signs of unrest. Ash emissions increased, small earthquakes became frequent, and volcanic activity triggered mud flows and hot acidic runoff that killed fish and animals. Ash fell steadily on the nearby city of Saint-Pierre, yet a government commission concluded that the volcano's activity did not warrant public alarm. Political factors complicated the response. A critical election was scheduled for May 11th, and the governor was reluctant to order evacuations that might prevent voting. On May 8, 1902, shortly after 8 a.m., Mount Pelée generated a pyroclastic flow, a high-density mixture of hot gas, ash, and rock moving at hurricane speeds. This mixture swept down the volcano's slopes and engulfed Saint-Pierre in less than 1 minute. Nearly everyone in the path died. The city of Saint-Pierre, with its population of approximately 28,000, was destroyed. Buildings were flattened or incinerated, ships in the harbor capsized or caught fire. Only a handful of people survived. The most famous survivor, Ludger Silbaris, was ironically protected by being in the city's underground prison cell. Another survivor, Havivra da Friel, reportedly survived by taking refuge in a cave near the shore. The Mount Pelée disaster fundamentally changed the study of volcanoes. Before 1902, the primary volcanic hazards were thought to be lava flows and ashfall. The concept of pyroclastic flows and their capacity to annihilate entire populations in minutes was not well understood until after the destruction of Saint-Pierre. The 1985 Nevado del Ruiz eruption. The 1985 eruption of Nevado del Ruiz in Colombia demonstrates how even a relatively moderate volcanic eruption can cause catastrophic loss of life when combined with inadequate hazard planning and communication failures. The disaster, which killed more than 23,000 people, is especially significant because it was largely preventable. Beginning in November 1984, Nevado del Ruiz showed increasing signs of activity. Scientists closely monitored the volcano and produced hazard maps clearly indicating that the town of Armero faced extreme danger if an eruption melted the summit glaciers. On November 13, 1985, Nevado del Ruiz began a relatively modest eruption. Heat from the activity melted a significant portion of the mountain's glacial ice, generating fast-moving volcanic mud flows that rushed down the volcano's drainage valleys. Despite having hours between the start of the eruption and the mud flow reaching populated areas, a series of communication breakdowns prevented effective warnings from reaching endangered communities. Power outages, storm interference with radio communications, and confusion among authorities about who had the authority to order evacuations all contributed to the disaster. At 11:30 p.m., the mud flows reached Armero, moving at speeds up to 40 miles per hour and consisting of a slurry as thick as wet concrete. These flows engulfed the sleeping town. Within minutes, approximately 75% of Armero's 28,700 inhabitants were dead. The Armero tragedy gained international attention through the story of 13-year-old Omeira Sanchez, who was trapped for 3 days in the debris with water up to her neck. Despite rescue efforts, she died from complications caused by infection and prolonged exposure. The disaster led to significant reforms in volcanic hazard management worldwide and prompted the United Nations to declare the 1990s the International Decade for Natural Disaster Reduction. The 1792 Mount Unzen eruption. The 1792 disaster at Mount Unzen in Japan demonstrates how volcanic events can trigger complex cascading hazards that extend far beyond the immediate eruption. This event, which led to the death of approximately 15,000 people, remains Japan's deadliest volcanic disaster. Several months of earthquakes and steam emissions in 1792 culminated in the eruption of lava on the eastern slope of the volcanic complex. The instability created by this activity weakened the slopes of nearby Mount Mayama, a lava dome formed during earlier eruptive phases of Unzen. On May 21, 1792, a strong earthquake triggered a massive landslide on the Mayama Dome. Large amounts of material collapsed and slid into Ariake Bay. This massive displacement generated a devastating tsunami with waves reaching heights up to 330 feet in some areas. When these waves struck populated areas around Ariake Bay, they destroyed numerous fishing villages and resulted in the deaths of approximately 15,000 people. However, this volcano wasn't done yet. In 1991, nearly 200 years after the 1792 catastrophe, Mount Unzen became active again. During this eruptive phase, 43 people died by pyroclastic flows, including renowned volcanologists Maurice and Katia Kraft, along with American geologist Harry Glicken. The Krafts were famous for their close-range documentation of volcanic activity, producing films and photographs that dramatically improved public understanding of volcanic hazards. Their death occurred while documenting volcanic phenomena to help improve public safety. The 1991 to 1995 eruption sequence at Unzen caused more than $2 billion in economic damage and required the evacuation of approximately 12,000 people. However, improved monitoring systems and hazard management practices prevented the death toll from approaching the scale of the earlier catastrophe. The 1586 Mount Kelud eruption. Mount Kelud, located in eastern Java, is one of Southeast Asia's most dangerous and historically lethal volcanoes. Its 1586 eruption is regarded as its most catastrophic, with estimates suggesting that around 10,000 people died. What makes Kelud particularly hazardous is its crater lake. Before modern engineering interventions, this lake contained approximately 40 million cubic meters of water. During eruptions, this water mixes with volcanic material to form exceptionally fast and destructive volcanic mud flows that can travel dozens of kilometers from the volcano. The 1586 eruption explosively ejected much of this crater lake, sending massive volcanic mud flows down multiple drainage channels around the volcano. These mud flows destroyed dozens of villages across the fertile agricultural plains surrounding Kelud. Kelud's persistent threat led to one of history's earliest large-scale volcanic engineering projects. Following another deadly eruption in 1919 that killed over 5,000 people, Dutch colonial engineers constructed an elaborate drainage tunnel system between 1923 and 1929 to reduce the volume of water in the crater lake. These tunnels substantially lowered the crater lake's water level, significantly reducing the volume available to fuel mud flows during future eruptions. Despite these mitigation efforts, Kelud has continued to pose significant hazards. A 1966 eruption still caused around 200 fatalities despite the reduced lake volume. In February 2014, An explosive eruption sent ash more than 25 kilometers into the atmosphere, forcing the closure of 3 international airports and the evacuation of more than 200,000 people. What makes Kelud particularly challenging from a hazard management perspective is its eruption speed. While many volcanoes provide weeks or months of precursory activity before major eruptions, Kelud can transition from background activity to major eruption in a matter of hours. The 1783 Laki eruption. Beginning on June 8, 1783 and continuing for approximately 8 months, the Laki eruption occurred along a 27-kilometer-long fissure system containing 130 individual craters. Rather than a single explosive event, Laki produced an extended outpouring of basaltic lava covering approximately 965 square kilometers and totaling about 14 cubic kilometers in volume. What made Laki devastating was the atmospheric pollution it created. The eruption released an estimated 122 million tons of sulfur dioxide, 15 million tons of hydrogen fluoride, and 7 million tons of chlorine into the atmosphere. These emissions created a lasting haze known as the Laki haze or dry fog that spread across the northern hemisphere. In Iceland, the immediate effects were catastrophic. Fluorine poisoning from ashfall contaminated grass, leading to the deaths of approximately 80% of sheep, 50% of cattle, and 76% of horses on the island. This livestock mortality triggered the haze famine that led to the death of an estimated 9,000 Icelanders, nearly 20% of the country's population. The climate impact extended far beyond Iceland. The sulfur dioxide emissions created sulfuric acid aerosols in the upper atmosphere that reduced solar radiation reaching Earth's surface, cooling the northern hemisphere for several years. Across Europe, the summer of 1783 was unusually hot, while the winter of 1783 to 1784 was exceptionally severe. In Japan, the climate effects worsened the Tenmei famine, which caused over 900,000 deaths. Across Europe, crop failures and food shortages were widespread. Benjamin Franklin, then serving as American ambassador to France, was among the first to suggest a connection between the unusual atmospheric conditions and volcanic activity in Iceland. Some historical analyses suggest that the agricultural failures and resulting economic hardship in France contributed to social unrest that ultimately led to the French Revolution of 1789. While this connection remains debated, it illustrates how volcanic events can potentially influence political developments through their economic and social impacts. Thanks for watching. For more devastating disasters, check out this video on the deadliest tornadoes in U.S. history.